Okay, 7-5, trigonometric equations. We're going to solve algebraically and by using a graphing calculator. So the first thing to do is you need to think about your trig functions and try to figure out how you can manipulate them algebraically by factoring, combining, separating, whatever it is. And then if there's something that doesn't match, maybe you want to use an identity. And then once you get there, you want to actually solve for whatever it is you're solving for. You'll see what I mean. Alright, example 1, since find all the solutions exactly for 2 cosine squared x minus cosine x. What you want to think about is 2 cosine squared x minus cosine x equals 0. It's almost like this is 2x squared minus x equals 0. So if you pulled out an x, you'd have 2x minus 1 equals 0, so that you could solve it now. And then here you'd have 2x equals 1, therefore x equals 1/2. But really it was x is not x, it's cosine x. So it's actually the cosine of x equals 0, and the cosine of x equals 1/2. So what you want to think about is, where does the cosine of x equal 0? It equals 0 at pi over 2 and at 3 pi over 2. And then where does the cosine equal 1/2? It equals 1/2 at 60 degrees, which would be pi over 3. And it also, cosine, remember on your circle, the cosine is, we're looking at something that's positive, and cosine is positive right here. So also where it's at pi minus pi over 3, which would be 5 pi over 3. Okay, so now that you know those, it doesn't give you a restriction, so you could go to 2 pi, 4 pi, 5 pi, whatever, to infinity pi. So we need to take that into consideration. So we say that x equals pi over 2, and if you think about it, pi over 2 plus every 2 pi. So you can go around the circle as many times as you want going to pi over 2. Same with 3 pi over 2 plus 2k pi. Same with pi over 3 plus 2k pi. And 5 pi over 3 plus 2k pi. And you need to say that k is any integer. All right. Now it's your turn. Go ahead and pause and give it a go. Okay, check your answer. It's really important that you put k as any integer and you add in your 2k pi's, because it doesn't give us any parameters. Okay, now for example number 2, find all the real solutions for 3 cosine squared x plus 8 sine x equals 7. Here's what our problem is here. We've got a sine x and we've got a cosine. So we need to get them in the same thing. So why not use our Pythagorean theorem of cosine squared x plus sine squared x equals 1. And let's solve for cosine squared x. So cosine squared x equals 1 minus sine squared x. And plug that in for cosine. So now we've got 1 minus sine squared x plus 8 sine x equals 7. So 3 minus 3 sine squared x plus 8 sine x equals 7. And now we're just going to get it all positive. So I'm just going to take everything over to this other side over here. So now I've got 3 sine squared x minus 8 sine x, and 7 minus 3 is 4, plus 4 equals 0. Again, if you think of this as 3x squared minus 8x plus 4 equals 0, you can factor this. And what you're going to factor it into is 3x minus 2 and x minus 2. So now we've got 3x minus 2 equals 0. X minus 2 equals 0. So 3x equals 2. Therefore, x equals 2/3. And then x equals 2. But we're not talking about x, we're talking about sine. So we really have sine x equals 2/3 and sine x equals 2. Think about this one here, sine x equals 2. If you remember the graph of sine x, it only goes from -1 to 1, so this can't be true. But we can use the fact that sine x equals 2/3. Okay, it's your turn. Go ahead and pause, and I'll put the answers. Okay, so here's the answer. I hope you got it right. Okay, so example 3, we're going to take our equation of 5 sine of 2 theta minus 5 equals -3.045. Let's make x equal to 2 theta minus 5. So now we have 5 sine x equals -3.045, and we want to find sine x. So divide by 5, divide by 5. And now we want to get x by itself, so we're going to say x equals the sine inverse of -3.045 all over 5. And what you end up getting is x is equal to -37.5172 degrees. Now, something you need to think about is we were given a parameter of 0 to 360. So if we think about our circle, we're from 0 to 360, and we want it where sine x is going to be equal to, let's see, when we finally got sine x, we want it equal to a negative number, and sine is equal to a negative number in these two quadrants. So those are the quadrants we need. So let's go back to our formula here, and we've got x equals -37.5172 degrees. So to get that, which is going to be somewhere down here, we're going to go 360 degrees minus 37.5172 degrees, which is going to give us 322.4828, and then we need our other one where we're at 180 here, so we want this one, so we're going to go 180 plus 37.5172. Now we get 300 and, oops, excuse me, not 300. We get 217.5172. All right, let's make a little bit more room. All right, now all we have to do is we have to remember we said x equals 2 theta minus 5. We need to find theta. So 2 theta minus 5 is going to equal 217.5172. Add your 5, and you get 2 theta equals 222.5172. Divide by 2, and theta is going to equal 111.2586. We're going to do the same thing with our other angle. So 2 theta minus 5 equals 322.4828. Add 5, 2 theta equals 327.4828. Divide by 2, and we end up with theta equals 163.7414. And that's it. Okay, it's your turn to try it. Go ahead and pause, and I'll put up the answer. Okay, so here's the solution. I hope you got it right. Okay, example 4. We're going to find the exact value for sine squared x equals 1/2 sine 2x, and we're going from 0 to 2 pi, so we don't have to do the 2k pi where k is any integer. We've got parameters. So what we want to do here is we want to change our sine 2x, use our identity for sine 2x, and change it to, keep the front the same, sine squared x equals, and it's 1/2, and our identity is 2 sine x cosine x. So when we distribute, we've got sine squared x equals sine x cosine x. Get everything over. So we have sine squared x minus sine x cosine x equals 0. And notice we have sine that we can factor out. So sine x equals sine x minus cosine x equals 0. And now set them both equal to 0. Sine x equals 0 and sine x minus cosine x equals 0. If you think about where sine x equals 0 at 0 degrees and 180 degrees, or 0 and pi. And for this next one, we're going to take the cosine x over. We want to know where sine x is equal to the cosine x. All right, this one's a little bit more difficult, but all you have to do is kind of think about your triangles or your circles. Nowhere on the circle are they equal, but if you think about your triangles, think of your 45 and your 45. That's 1 square root of 2. The sine of 45 is 1 over the square root of 2. And the cosine of 45 is 1 over the square root of 2. So your answer is going to be pi over 4. Okay, but we want where either sine x and cosine x are both positive or sine x and cosine x are both negative. So here is where sine x and cosine x are both positive, and if you think about it, sine x and cosine x are both negative in quadrant 3, so we also want to use that. We also want to use that pi 4, so there's 1, 2, 3, 4, so our answer would be 5 pi over 4. All of these are your answer. Okay, so it's your turn to give this a go. Go ahead and pause, and I'll put the answers up. Okay, here's the answer. I hope you got it right. Okay, example number 5, we're going to do cosine of 2x equals 4 cosine of x minus 2. And cosine of 2x, we know that there's an identity for that, and I believe there's several, but we really want one that we have another cosine. So let's use the one where it says 2 cosine squared x minus 1 equals 4 cosine x minus 2. Let's take everything over, and we've got 2 cosine squared x minus 4 cosine x. Bring your 2 over, plus 1 equals 0. Okay, now you can't factor this one, so you're going to have to use the quadratic formula. So we've got negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we've got a positive 4 plus or minus 16 minus 8 all over 4, which is 4 plus or minus the square root of 8 over 4. 8 is 2 times 4, so 4 plus or minus 2, square root of 2 over 4. We can cancel out our 2's and get 2 plus or minus the square root of 2 all over 2. And now we're just going to find the decimals for that. The decimals, and come back up here. When you solve it out in your calculator, you get 1.7071, and you get 0.2929. Now remember that we're talking about the cosine of x, and cosine only goes from 1 to negative 1, so that can't be it. This would be our only possibility. So now we have that the cosine of x equals 0.2929. So let's find the inverse so we can find our angle. And when you do that, you end up with x equals 1.2735. And we're looking where cosine is positive. So if you go through here. All right, so remember we have to think about where is cosine positive. Cosine is positive here and here, so that's the angles we're going to think about. So our first one, we're not going to change any, so we're going to keep this one. But our second one, we're going to have to go 2 pi minus 1.2735. And for that, we'll get 5.0097. Okay, now we don't have any parameters, so don't forget. You have to go 1.2735 plus 2k pi, and and then 5.0097 plus 2k pi, where k is any integer. Okay, it's time for you to pause and I'll put the answer for you. Okay, here's your solution. I hope you got it right. Let's move on. Okay, these ones are super simple. The hardest part is plugging it in the calculator. So here's all I did. Hold on, let's make this bigger so we can see our graph. All right, all I did is I plugged it in. So I said that y1 is equal to 2 cosine 2x, and then I said that y2 is equal to 1.35x minus 2, and all it wanted to do is for you to find out where does it intersect. So the answer is it intersects at x equals 0.9639. That's all you have to do. To find that intersection, press second calc, number 5, which is intersection, put your little x's, and you're good. Time for you to press pause. Here's the solution. Okay, let's move on. Okay, again, this is going to be really simple. Just plug it in your calculator. So for y1, I put in tangent x over 2. For y2, I put in 1 over x, and then in your window, you have to add in your parameters right here, which is going to be your x's. So your x min would be negative pi, just negative pi, and then your x max will be 3 pi, and for the scale, I like to stick with pi over 2. Graph it. Find out where they intersect, right here, and right here, and your answer would be x is negative 1.3065, which is this one. X is 1.3065, which gives you this one, and the last one is 6.5846. Time for you to pause. Okay, here are your 3 answers. Let's move on to the next. Okay, so far you've been doing these just by plugging them in the calculator. This one just gets a little bit more involved, but not much. Let's look at the graph, and let me spread it out so we can see it good. The only thing you have to worry about here is it's an inequality, so you're looking for something that's less than or greater than. So if we take a look here, all right, so my y1 was sine x minus cosine x, and my y2 was 0.25x minus 0.5. Notice that it says that sine x minus cosine x is less than that line. So that's what you're looking for, is you're looking for where it is less than. And if you'll notice, it's less than in this area here. You want your sine x cosine x to be less than, and it's less than here as well. So if we take a look at these points, what we've got is right here and right here. We've got that interval. Just again, use your second calc and go to intersection. And your answer, it's going to be open because it's only less than negative 1.652. 0.52. That takes care of those two. Union. Now you need this one, which is 3.63, and notice it's going on to infinity, and you're done. Time for you to pause. Here's your answer. The tricky one about this is where you wanted the cosine x minus sine x greater than. All right, here's your homework for day 1 and homework for day 2 because we're taking 2 days on this.